Algebra is the way in which we describe patterns and solve puzzles. It gives a simple mathematical way to describe real-world questions and uses letters called variables to represent unknown values. A term is either a single number, a variable, or a combination of the two. Terms are separated by operations such as addition or subtraction signs. Like terms are any terms in an algebraic expression that have the same variables with the same exponents. To simplify this equation, we must first combine the like terms. The first term, 3x squared, and the third term, x squared, are like terms. They share the same variable x, with the same exponent 2. We can combine these two terms by combining their numerical coefficients. The first term has a coefficient of 3. The third term has no numerical coefficient shown, which means the coefficient is 1. 3 minus 1 equals 2. The result of combining these two terms is 2x squared. Let's continue. The terms 2x and the term x are also like terms. 2 plus 1 equals 3, so the result of combining these two terms is 3x. The last terms, y and 1, don't have any other like terms in the expression, so they will remain. Let's work an example. You own a pool company that offers rectangular pools that come in all sizes with decorative brick along the perimeter. No matter what the size, the length of the pool is always 5 feet longer than the width. You need a formula to help determine the total amount of decorative brick required per job so that you can generate quotes more efficiently. The perimeter of a rectangle is found by adding up the measurements of all 4 sides. Since each side is equal to its opposite side, the formula for finding the perimeter of a rectangle can be written as 2 times the width plus 2 times the length. Since the pools come in all sizes and you need a formula for all pools, we're going to change the word width with a variable x. Anything could be used for the variable: the letter W, an empty box, a picture of a pool, or even the word width. It's easier to simply write in a single letter. For this example, we'll use the letter x. Since the length is equal to the width plus 5, the binomial x plus 5 can be substituted for the word length. Using the order of operations rules, accomplish the operations in parentheses first. Since the terms are not like terms, there's no addition or subtraction to be accomplished at this time. Moving on to multiplication and division, multiply 2 times x, which simplifies to 2x. Next, 2 times x plus 5 simplifies to 2x plus 10. Finally, combining like terms leaves a formula of 4x plus 10. Now, no matter what the size of the pool, you can easily determine the quantity of decorative brick required and give an accurate bid for each job. Here's another example. You're the head landscaper for a planned housing community. Both houses and lots come in different sizes, but all houses are 5 feet longer than they are wide, and each lot must be 10 feet wider and 20 feet longer than the width of the house. You're responsible for ordering sod to complete the landscaping on each lot. Write an algebraic expression that will help you quickly and easily determine the total amount of sod you'll need for each lot. First, determine the total area required to sod. The formula for the area of a rectangle is width times length. But in this case, the area that represents the lawn is a rectangle minus the rectangle that represents the house. So the total area required for sod is the width times length of the lot minus the width times length of the house. Substituting in the values from the diagram will give a formula for the area. The width of the lot is x plus 10. The length of the lot is x plus 20. Since the total area of the lot is needed, these two expressions are multiplied together. In algebra, we don't use the symbol x to represent multiplication because it would make the equation look too confusing. Instead, we either use a dot or place terms next to each other, as in this example. Next, subtract the area of the house. The width of the house is represented by x, and the length of the lot is x plus 5. These two expressions must also be multiplied together to represent the total area of the house. Following the rules for order of operations, accomplish any operations within the parentheses first. Since there's no multiplication or division, and none of the terms within are like terms that can be added or subtracted, no work is necessary within the parentheses. The next step is to accomplish any multiplication or division from left to right. The first items multiplied are x plus 10 times x plus 20. To multiply these binomials, multiply the first terms, the outer terms, the inner terms, and the last terms. Multiplying the first terms yields x squared. Multiplying the outer terms yields 20x. Multiplying the inner terms yields 10x. And multiplying the last terms yields 200. Next, accomplish the multiplication of x and x plus 5. X times x is x squared. X times 5 is 5x. Since the entire binomial is being subtracted, change the sign of each terms. The x squared becomes minus x squared. Similarly, the addition sign in front of the 5x becomes a subtraction sign. Now, simplify by combining like terms. X squared minus x squared is 0, so this term cancels out. The term 20x is a like term with 10x and 5x. 10 plus 20 minus 5 is 25. So our final term is 25x. The term 200 is the only simple number, so it remains the same. The final equation that represents the amount of sod needed to landscape the lots in the new housing community is 25 times x plus 200, where x represents the width of the house. In this example, the local building code requires all roofs to be a minimum of 7 on 12 construction. That means for every 7 feet increase in vertical height, called the rise, there must be an increase of 12 feet horizontally, called the run. An installer may be required to place a satellite dish in various places on a roof, depending on its position and any obstacles already installed. Write an equation that will help the installer determine the vertical height of the satellite dish from the eave of the roof so that the electrical cable required for each job can be calculated. To determine the vertical height of any point along the roof line, first determine the equation for the line. Any straight line can be written in the format of y equals m times x plus b, where y is the vertical distance, m is the slope of the line or how steep it is, x is the horizontal distance, and b is the y-intercept, which is the point where the line crosses the y-axis. This equation format is called slope-intercept form. First, let's assign an origin for the x and y axes. Coordinate axes simply allow a frame a reference by which you can measure, so it doesn't matter where we set the origin of the axes. However, if you choose a strategic place to put your coordinate axes, you can make future calculations much simpler. For this example, the origin is at the bottom eave of the house. The origin always has the coordinate 0, 0. It's literally the starting point of any measurement. Let's apply this format to the line that represents the slope of our roof. Start with y, which is the vertical distance we want to find. Next is the slope, m. Our slope is defined by the local code, which stated that for every 7 feet of rise, we need 12 feet of run. So the slope for the roof is 7/12. The line of the roof is sloping upwards away from the origin, so our slope is positive. If the line were sloping down and away from the origin, the slope would be a negative number. X represents the horizontal distance and B is the y-intercept of the line. The y-intercept is the point at which the line crosses the y-axis. This point will always have an x-coordinate of 0 since it's vertically aligned with the origin. But the y-intercept can change depending upon where the line crosses the y-axis. Since we chose to put our origin at the eave of the house, which is where the roof starts, the roof line crosses the y-axis at the origin, which has the coordinates 0, 0. The y-intercept, B, is the y-coordinate at this point, which is 0. Now the installer has an equation that accurately represents the location of the satellite dish in relation to the eave. To determine how much wire is needed, the installer can substitute the horizontal distance from the eave to the dish and finish the calculation.